Okay, hi and welcome to my session on exploring source generators. So my name is Martin. I'm from Vienna in Austria. I work for Tieto. You can also find all the source code I'm showing on GitHub. Also, I'm very active on Stack Overflow, usually in the MS Build area. And I work for a company called Tieto, which also has some offices in Norway. So what I want to do with you today is I want to talk a bit about the motivation behind source generators, the hows and whys. But I also want to show you some features in .NET 6 and .NET 7 that you can actually use to improve your applications a bit. And there are some source generators that help you with that, and you may already be using some of them, possibly without knowing that. Also, I want to show you how to write a custom source generators. So we'll be doing an N+1 version of the property change generator. And I'll also show you a bit about the new features that are in Visual Studio 2022, called incremental generators, and give a few tips and tricks and pointers what you should do if you really want to write your own generator and want to ship it to production. So on meta programming, it's a very helpful tool. You do want to avoid writing boilerplate code. So when you find yourself writing the same stuff over and over again, you usually want to automate that a bit. So things like that have been around for quite some time, but there are different things you can do with it. So you can try to rewrite your code. For example, aspect-oriented programming does that if you want to do some fancy deadlock detection, or thread synchronization if you want to do debugging or logging every method call that exists. There are tools that can do that. But I think the most common ones are usually serialization. When you have JSON serialization logic, XML serialization logic, you want it to be fast, and that means it should be near native code. So not a lot of reflection method invoking going on, but rather code that was actually generated either at runtime or at compile time. And also what you likely have done is use some OpenAPI specification or WSDL schema to do some API calls. So usually you have some known schema or some data, and you just want to have the code generated to for either the data models or the data access logic. In .NET, there are a few ways to accomplish that. First of all, there is reflection. It's a very powerful tool. It's very mature in .NET, but it's also not the fastest thing you can do. Especially, reflection is usually done when you try to do something the first time. So it's one of the things that adds time to any startup time you have. Just scanning all your classes, scanning attributes, generating some metadata that you would need to know, for example, for JSON serialization, and something you could probably also do ahead of time. Then there is IL generator, so you can dynamically emit the intermediate language code at runtime. This is usually done in combination with reflection. So you would, for example, generate a method that does all these set calls based on some data that is coming in. So you don't have to do the reflection or the method info.invoke calls all the time. This is quite hard to do. It's a pain to debug if there's anything wrong with that. And again, it is jittered. So if you want to run in ahead of time compiled runtimes, it might be a bit problematic. There are also custom build steps. So for example, for nearly 2 decades, we have XML serializer, which has a build flag that you can set in the project properties. We can say, yeah, I want to have all the serialization assemblies generated ahead of time. So you get the .xml serializer.dll, which already contains the XML serialization logic. So that reduces the startup time that is needed for doing the first XML serializations. And also, I think in .NET Framework, the first time you use XML serializer is actually not thread safe if you don't do that. So at least it used to be. Also, ASP.NET Core used to generate its own views DLL. That changed in .NET 6. And of course, if you have some tools that, for example, protobuf, you have some proto files, you would have some tool that runs during the build process that takes these proto files and generates some C# code out of that. What you can also do in custom build steps is do the reverse. So you could have code or compile code and then generate some definitions or schema files from that. So that's also something you would usually do in a custom build step. And of course, there is there are IL weaving tools. So these are tools that technically it's also a build step, but it looks at your compiled DLL file and modifies it in some way. So it doesn't really touch the source code. So for example, no C#, no Visual Basic. It would just operate on the intermediate language level on the DLL file. That's also very, very hard to do and very easy to mess up. So there's a lot of time involved in doing that. So that's also why the FODI project switched the license to, yeah, you should contribute financially to a project if you want any changes to be made. And also PostSharp is a tool that I highly recommend for some advanced scenarios, especially at aspect-oriented programming. But in C#9, so that's now nearly 2 years ago, we got a new feature in .NET, or actually in the compiler called source generators. The scenarios that are supported by this feature is actually limited to adding C# code to your project. So you cannot really rewrite anything. So if you have an existing method implementation, you can't really change that. So if you need to do that, IL weaving is probably still the best option out there. Otherwise, you would have to do some fancy magic with interfaces and so on. But the advantage is it runs directly in the compiler. So you don't have to use any MS build glue logic, and also it can be done in a single compiler run. So for example, there is one generator that I wrote some time ago that used a different framework, but the downside was that it had to load all the C# code, parse it, generate a semantic model, generate the actual code, and then throw it all away. So you basically had a whole compiler run before the actual compiler run. And that is quite expensive. If you can do it directly in the compiler, it's a bit easier. So the compiler at some point just stops, asks your generator, yeah, is there anything you want to contribute? Here's the current state of the compilation. Here's everything I've already parsed and analyzed. And then you can just add more source code to it, and it would continue. You can also have multiple generators. They would all see the same source state. So if you have one generator that generates some code, you can currently not chain the generators one after each other. Just the most discussed topic is just how would you do the ordering and do not mess up anything, basically. There's also some links I want to point to. So there's the source generator cookbook that basically tells you how to use most of the features that are available. And there are some SDK samples as well. But, and I think that's the most helpful, there are lists of source generators that you can just get from NuGet and use in your project. So if you find anything that's useful to you, have a look. Or if you find yourself writing something that you think, yeah, someone probably has already implemented that, go check here. So with that, I actually want to have a look at the source generators that are now in .NET 6 and 7. So we got source generators, then a year later, the first .NET features started using them, and now even more. So let's have a look. So the first thing I want to show is actually JSON serialization. So in .NET, we had this kind of new system text JSON namespace that allows us to basically serialize and deserialize JSON files. So I have a sample JSON file in here. I have a class that is supposed to hold the data, and now let's try to run this. Okay, it worked. It read both entries and then serialized them again to a JSON file or JSON text. The downside with that approach is that system text JSON on the first call to the JSON serializer would have a look at the class, do some reflection to find out which properties are used, which types are used, how to do any type conversions. And for serialization, it would also use reflection or generation to write out those JSON texts. But if I want to pre-compile the logic, because the class is known at compile time, I can also generate that information at compile time. And the way to do this is to create a class that derives from JSON serializer context. So on that context, I can put attributes that tell the system, yeah, I want to be able to serialize and deserialize lists of person. And it would do everything that would be necessary to pre-generate that code. So that should already work. Let's have a look at the dependencies. So the way these generators work is they're actually compiler plugins. And they make use of an existing compiler plugin functionality, which is analyzes. Those are the things that give you the squiggly lines and the completion options or the replacement options and code hints and so on. And generators use basically the same interface. So a generator can also emit diagnostics. So if I make some mistake or something can't be generated, a generator could also emit some diagnostics. So, and in .NET 6 and above, we should have the JSON source generator analyzer, and that generated a lot of code for us already. So, since the thing is partial, let's go to some interesting thing in here. So it had a look at all the types that were necessary. So we have an integer, we have strings, we have ilist, but we also have person. And what it does, it generated a lot of code that contains all the information it would normally try to derive from a class at the first time startup. So for example, it has a list of all the properties in here, so it knows there is a first name property. It generates a static getter and setter function, has all the metadata, and so on for all the properties that are involved in my object, or that the object contains. Also that something should not be serialized, like in this case, or does not have a setter. If you have some converters or something more advanced, that might actually not be possible. So if you do some modifications at runtime, you can't use it, but everything that is known at compile time and doesn't change, go ahead and use that. But also in addition to this reflection functionality, it also has a serialize handler. So it really generates the code, write start object, write string, write property name, write end object. So it really has the code to just generate all the tokens that are necessary directly into an UTF-8 JSON writer. So that is already pre-compiled. It's also possible to customize that. So it can specify, yeah, please emit everything you can, which is the default. But I can also tell you, yeah, just emit this metadata that you collected for reflection, or just generate a serialization logic. So if there are some more advanced features of system text JSON that you would use that are incompatible with that feature or that code generation, you can pick and choose what you need in here. I've had no problems using the default. And the way you would use that is in the deserialize method. I can use my person JSON context, the default instance, and ilist person. Now I no longer need the generic annotations. And it will use the pre-generated methods already. Same goes for the serialization. So I have the serialize call. I can call the person JSON context default ilist person. And that should then use the serialization handler that was pre-generated. Let's have a quick test. Perfect, and it works. So something you can probably already make use of in any web APIs, in any API calls, such as JSON serialization logic. It will make the first-time startups a bit faster, especially if you have very large data models and need jobs that complete quick with low CPU, like I'm currently doing in Kubernetes, so that helps a lot. Okay, so the next thing I want to show you is actually logging. So we have this Microsoft Extensions logging functionality that provides us all the iLogger and logging abstractions. So you no longer need to be specific to, for example, log4net or serilog. You can have this abstraction layer. And then you would usually call this .log information and so on. And there's now a generator that helps you do that and be a little bit more performant. And also if you have any things that have context, so for example, if you have, the order of these parameters don't match the call or the order of that you want to pass the parameters, it can also generate some structures. Just let me show you. So the way we do this is we mark a class as partial, and then we can create a partial function and with the parameters that we need, and tell the generator, yeah, please generate a logging call for me with our message template and the log level. And I should be able to use that in here. And what this generates, so this is now logging generators, is first of all, it already generates some callback functions, so we have things already defined globally, but it also emits the isEnabled call, so we don't do any serialization or string formatting if it's not actually needed. So if you're not logging information level, it would just skip it and then do the actual logging call. If I switch things around and change the order, it should also generate a struct that holds the information and has the appropriate toString method. So just things to help out here. What it does, it just tries to find, okay, I'm on a class, is there any iLogger or iLogger of T member defined, and it would just use that one. Of course, what I like to do is have some extensions, so if you have some extensions, that also works. If you have this iLogger and I want to log method enters and exits, I can also do that with the generator. Also note, I can also set the event IDs, event name, and so on. So that should compile cleanly. So also, now that we're talking about web applications, so this is now a Razor Pages application. So I have the layout, for example, that is a Razor page. And the way Razor works is it actually generates C# code for that page and then JITs it, or used to JIT it at runtime. But they introduced precompiled views, so that would be done at compile time. And now this is actually moved to a source generator. So I also did something else in here. I also set a magic property in the project file, emit compiler generated files. So for example, if you did not have use an IDE that actually shows you the analyzer output, I can also have a look at that code in any other editor. So for example, here it generates it in the object folder, generated, and then every generate output would go in here. So for example, if you have a CI system and you want to do some static code analysis on even the generated code, you can also do that to be able to do that. And what it then generates is a class for all the Razor files, and then have the write literals, do some tag helper execution mixed with write literals, and so on. So all the code that you wrote in Razor is just compiled, put into a C# version, and then compiled alongside your other application code. And that is already in .NET 6 and .NET 7. So let's switch back. one of the things that is actually new to .NET 7 is there is now a regular expression generator. So if you're using .NET 7 and you find yourself using regular expressions quite often, also regular expressions are runtime compiled because they need to be fast on execution. So there is a state machine that builds up for a regular expression. And now in .NET 7, you can annotate a static partial method with a generated regex annotation. So for example, this is an IP regular expression. You can also have some additional parameters. So if you want to set some regex options, you can do that as well. Yeah. GitHub Copilot is already suggesting me something that does not make sense in here anymore. And what it will generate is code that I definitely do not want to write myself. So first of all, it gives you an explanation of what this thing actually does. So that is actually also visible in the tooltip. So if you want to see how your regular expression works, that is the explanation. And then there is also the implementation. So I'll just scroll over that. So there are loops, capture groups, go-tos with some branches. So that's the actual state machine implementation that you will get for your regular expression. And that's actually quite a lot. And it has go-tos, but never mind. And again, that should be faster than doing it at runtime. Also in .NET 7. So, and I'll try to actually run that. If you have ever called into any native method, so things that are like a Windows API, iOS, Mac APIs, or just any C library, you would have these things that you marked with DLL import. And a feature in .NET 7 is you can switch out DLL import for library import. That would pre-generate all the marshalling logic, and also has some different options to be able to configure it than the traditional DLL import. Also, so it gives a bit more control, but also does a lot of the code generation at compile time. So for example, there is a function in kernel 32.dll called global memory status X that I can use to get the current memory status. So I have a struct in here that I pass back and forth between the native code. Let's just run that. So it says my memory load is 34%. And I already have quite a large page file. And what this generates first of all, it generates unsafe code, so it uses pointers. So you will need to enable unsafe code for the project that you're using it in. But it will do all the marshalling that's necessary in this case. It's just getting a pointer for a struct, to be able to pin it in memory, and then do the actual pinvoke call, which is still done using DLL import, but any code that the runtime would need to generate is already pre-generated. There are other examples I can show. For example, there is a library I've written some time ago to deal with Windows services. Because in .NET Core 1, we did not have service base or any service base code that was in the license that allowed us to copy that. So I had to kind of write my own. So that means interfacing with Windows APIs to manage services and also manage, be able to run as a service. And so there are a lot of interop calls I had to do. And just to show things that are possible, for example, I can set string marshalling behavior. So are these UTF-16 characters, are these ANSI strings? In that case, it's a Windows function that ends in a W, so wide characters, which means 16-bit strings. Also, what you can do is you can use classes that derive from safe handle. which help you with memory managing any native resources that these native functions allocate. So for example, if I create a service, then it gives me back a service handle, which I derive from save handle, that basically holds the pointer. And if I forget to close the thing, the garbage collector would automatically do the correct cleanup call, and I would close the service handle. And if I want to have a look at the code that this now generates, it's a bit more. So it knows how to do the UTF-16 string marshalling. It knows how to call all the dangerous functions on service handle. Also, it skips locals in it to be just a little bit faster. Takes care of the last error handling, more dangerous functions, and also does the handle initialization of these safe handles. So that's all code that the runtime would normally generate or do dynamically, but I can now pre-generate it. It's especially useful on platforms like iOS, where you have ahead-of-time compilation and maybe need to do some more specific marshalling of things. So okay, there is one more. I will just quickly show that. So for WebAssembly, there are also now new interoperability functions, basically JavaScript import, JavaScript export. So if you're working directly with the WebAssembly runtime, you can use those as well to basically call any JavaScript function of an imported module or make some functions available to JavaScript code. So, oops. For example, I could call the myClass.greeting, it would call myClass.greeting, and this also creates a fake or a model import and the things that will be available to the runtime. If you're using Razor or Blazor WebAssembly, there's still the IJS runtime, which is still the preferred way to do interop, especially because you can pass element references back and forth. But if you want to do that manually, that can be done as well. So since Visual Studio is currently not able to run that, nope, fine. So, greetings from localhost and that port. So, we can actually see that this works. Now, just a short recap. Again, you have the JSON serializer, which with different options on what you might want to choose for the different serialization objects. It is actually a lot faster for the TechEmpower benchmark. It does caching. So the things where you have to do a lot of in-memory caching of JSON objects, it showed a 40% increase just going from .NET 5 to 6. Should already be a bit fast in .NET 7 as well. If you want to use that in your web APIs, you can do that by configuring the JSON objects of your APIs, where you can add the context that you can have all your model classes in as well. And if you're using HTTP client for any APIs, you can also pass it to the context property or the property that contains all the information directly to the HTTP client function. So there are new overloads as well. If you run into troubles with the Razor source generator, you can still turn it off. I did not have to do that except for one instance, and that was fixed in a recent .NET upgrade. You have the login generator. You have the regex generator in .NET 7, library import, and JS import. But the fun part is when you write your own. So let's do that. So again, who has already implemented iNotify property changed before? Yeah, so that's an interface that has one event that is supposed to fire whenever you change a property. So I have a view model here. I want to have registered to a property changed event, log something, and then change some properties. But I don't really have an implementation yet. So there are already hundreds of ways to implement this. I'm going to add one more. And that will use an interface to define how the shape of the object should look like, and then an auto-notify attribute that should implement these properties, and also the property changed event. The way I'm going to do this is I'm going to create a generator. So what I've done here is I referenced two NuGet packages that give me the Roslyn APIs to implement both analyzers and source generators, and the magic interface is iSource generator. I can also tell it if it should be available for C# or Visual Basic or both, and it basically gives me two entry points to set something up that I need to do anyhow, and then the execution step that is called during the compilation. So what I would do in here, first of all, how do you actually test this? Because if I load these things while I develop into Visual Studio, it will actually lock the assembly or it cannot read the update. So I really recommend developing this from unit tests. And the way you can do this is you can use a framework called verify, which basically is like a half manual, half automated test. So you basically tell it, okay, the state I'm in now is what I want. If anything changes, ask me if that's the correct change. So something you can set up. It's called verify source generators. I suggest you look it up on GitHub if you actually need to do this. But yeah, I can set up a compilation with some source code and run the test. Let's just see if that fails. Yeah, it fails. So let's implement that. First, I want to make sure that I actually have that attribute available. So there are two ways I could do that. I could add a reference to a DLL that contains the attribute, but I'm already generating source code, so I'll just add a file that contains the attribute. So this auto-notify attribute will be part of the target project. So I'm calling register of post initialization, and I will just add a source with the attribute containing this attribute code. In this case, there's also the conditional attribute on here. So if I compile for a configuration that is called just like the string, the attribute would actually end up in the resulting DLL. For anything else, like debug, release, whatever, it would just not end up in the DLL file. Then I actually want to have some data structures that I want to use. So I want to be looking at the source code, find all the things I need to generate, and to hold that information, I have this class. So I want to keep track of which type I need to generate and which interfaces those need to implement. A bit about the types later. And the way I look at the code is I can use a feature of Roslyn called syntax receivers. So this is basically a visitor pattern where I tell the compiler, yeah, I'm interested in any syntax, please give me your syntax nodes. And it will tell me, hey, here is a syntax node, are you interested in that? And I can do things with it. So that's actually the fastest way to iterate through the syntax tree. Because if I want to do it myself with some for loops or enumerators or even link, that might be a bit slower. So I also need to tell it that I want to do that. So I can register for the syntax certification with my syntax receiver. Now, speaking of syntax, how do syntax trees actually look like? So Roslyn has two kind of data models for code. One is the syntactic model, which is basically just the code and tokens that you wrote lexically analyzed. So it would know, okay, class and maybe there's a class keyword and so on. And then there's the semantic model, which actually tries to understand the code and map all the types. So for example, I should know that in that case, this is a syntactic model, and it just says, okay, there's an identifier, but no semantic information about what that reference type actually is. And also, that is a tool that I highly recommend, sharplab.io. It can show you syntax trees, it can show you decompiled versions. So if you want to have a look at how some compiler features work behind the scenes, you can have a look at that. And you can also use compilers generated from or built from some branches of the Roslyn repository. Okay, so let's see what we're interested in. We're interested in class declarations that have an attribute list with some attributes. So I want to have a look at that. And the way to do this is first to open up the right one. So I get any type of node in here, and then okay, if it's not a class declaration or it doesn't have attributes, I'm not interested. And then I need to make a switch from the syntactic model to the semantic model, because yeah, I now have a class definition with some attribute, but I need to know if that attribute actually refers to the one that I generated. So if you have something else that is called auto-notify, that might be a problem. But I can then check, is this really the class that I'm interested in? If so, I can pull out all the interfaces that it specified. This already is the semantic model, so I could later on ask it for all the property names, so I can keep track of what I need to implement. Also, what I should also note is do not rely on everything to be set up correctly. So if I have that attribute and the constructor call is broken, I might still get that result, but with the things either null or not set or not existing at all. So always remember, it could be in any in-between state of the person writing the code. Then I want to have a function that actually knows how to generate the C# code. So custom function that from this object that holds the data generates the C# code. So that this looks like a bit of a text editor, which appends like the auto-generated line. And of course, I don't know, or I actually have to find out if the target project is using null upper reference type or not. So if I want to do some special generation for these cases, I should also check that myself in the code and generate different code based on that. So it generates this event, property changed, and then for each interface, which property emits the both a backing property, backing field, and so on, and the actual property with a getter and a setter that sets the value of the backing field and raises that event. So now I need to wire this up. So I'm using the execute method. So before the execute method, my syntax receiver should already have received all the notifications. So I can pull up everything else that I need. So for example, I need to know, is that project using null reference types? And then go over my data objects, generate the C# code for that, and then use the context that I get passed in here to add these source files. Now let's have a look if that is complete. Yeah. Because I updated the project to new verify version. But there's another way to test this. I can actually reference this in my target project. Usually I would do that via NuGet. If not, I can directly reference the project, tell it, yeah, that's not an actual dependency, as in like a classical .NET dependency, and please add that as an analyzer. So let's see, yep, that seems to work. Can't guarantee it actually works when running, but let's see. So this generator shows up here. It generated the attribute, and it generated the implementation. So that now actually has a chance of running. Yep, it seems to work. It knows which property changed. That also means I can't show you what I like to use this verify framework for, but for example, if I wanted to change this getter to an expression-bodied member, what should happen is the test should fail and say, hey, this changed, is that okay or not? So it opens up a diff, yeah, that's what I was looking for. It opens up a diff and says, hey, something changed, is this okay or not? And then I can actually accept that, saving, and then the test should run again. So this is just a half-automated way of testing things. That's also very useful if you're dealing with lots of data objects and want to not code a lot of if this object or that object equals something. That's a very powerful framework to use for that. So then I also hinted that there are new features in Visual Studio 2022. So if you're first starting out to write a generator, I really recommend using that interface. But in Visual Studio 2022, or actually Roslyn 4, there are new APIs that you can use. The idea is that in the IDE, running a generator means at some point pausing any compilation, running all the generators, parsing all the files, if you have any syntax receiver or anything else that needs to be done, doing all of that for all the code, and then adding the source files and then parsing them and continuing. But if I want to have code generation on after every couple of keystrokes, that's not that performant. It would probably not matter for the generator that I just wrote, but again, there is a new API called incremental generator. The difference is this only has one method called initialize. And the way it works is it has similar methods or similar concepts, but it looks a bit more like a link query. So you're basically setting up a graph of things that run together into outputs. Just let me show you that. So we have a similar thing, register post initialization output. But then I have providers, a compilation provider, and then select statements, which is basically a transform. So I can tell it, yeah, I want to have a feed that tells me if these options are set or not. And then that has a type, okay, can't be read, called incremental value provider. And you can think of that sort of like a stream, sort of like an IEnumerable. And this is the same for all the other things. So for example, there's a syntax provider that I can ask to have some predicate that it should apply to all the syntax and just pass me the things that I need to have a look at. I can then create my own implementation generate and then have these where functions, select, combine, and so on. Those really look just like any link operator. And then I would register the output, which basically would like be a to list on an IEnumerable. And the way this works is this sets up a graph, and the IDE tries to only re-execute parts that are changed. So for example, if I have two classes that come in here, and if just one of them changes, I would only regenerate this data object for one of them. It would still know that there are two, it would have that cached in memory. So every step in here is actually cached, and then only the things that changed are updated. So it would just start running here if just one of them changed. So that is meant to save some compilation time if you're working in IDE scenarios. So yeah, we had that. Just some couple of more things you could do. One very probably important thing is you can use additional files. So if you have like a schema file, any data file, Excel files, whatsoever, you can mark them with a build action as C# analyzer additional file. In MS Build, it would just be called additional file. And these would be available in the generator as well. So you could read that file. For example, it could be a protobuf file, could be a schema JSON file, and generate classes from that. So that's quite useful. You can also put some metadata on that. So if you're more deeper in the build layer, you can do some customization. So I can tell the build system, hey, on the additional files objects, there should be this metadata name, in this case generated model namespace, that I want to set on these items. Please make them available to the compiler. And then on the files that I actually reference as an additional file, I can just set that metadata or property. Yeah, let's not use property, that has a different meaning in MS Build. I can set that metadata to some value, and it would make that available in the analyzer. There's also ways you can, if you do that in NuGet packages, there are also ways to make those metadatas and values also show up in the Property Explorer. But you need to write XAML files for that. Of course, there are also project file properties. So if you want to have something that is on the level of a project file, or you want to configure in there, you can also tell the system, please make some property compiler visible, so compiler visible property, and you can set that. So this will be your custom property. It's also one of the benefits of MS Build is you can basically define any property, any item that you want, and wire it up with existing logic. So this is now in the analyzer config options, where you can get all of these informations back out. Also, if you actually want to ship an analyzer, there are some questions that just a short checklist you should think about. First of all, I mentioned C#. You generate the code. Which version of C# are you actually generating for? So if I write now my perfect .NET 7 generator, and someone tries to use it on a C#9 application, maybe that doesn't work, maybe that works, we don't know. Same for nullable reference types. If you expect it to be set or unset on project level, make sure that the code files that you generate fit into the rest of the project. Also, since we're already basically an analyzer, since it uses the same plugin architecture, we can also emit diagnostics. So if, for example, if we expect some values, for example, in the C# login generator, we expect all the parameters of the method to be used in the message template. And if not, you can actually generate a diagnostic. So we would have a squiggly line that says, yeah, that one is actually not used in a template. Please change something. These are also things you can do from an generator. Also, and I've run into that, if you don't generate your code with an auto-generated annotation, some static analysis tool might complain because they would load the project, run their own checking logic, and then say, yeah, you did something wrong. For example, you used gotos in your regular expression. So just something to think about. Also, again, you may want to support different versions of the compiler. So you could want to have maybe your incremental generator for your projects, but maybe you still want to use the Visual Studio 2019 with maybe .NET Framework projects, like ASP.NET projects. So that would not be able to run incremental generators. Just think about that. Also, there is the cookbook, which will show you how to set up the NuGet package and use those features. So There's just some magic things you need to do to be able to pack that as a NuGet package. It's all documented. And again, if you want to write one yourself or use one, there is a great list on GitHub. I linked it in the presentation, which shows you some of the available generators that people wrote. So you can have a look if there's anything you might want to reuse. So the list is already quite large. Right. The reason that got me into this was actually data builder patterns, because I used to write applications that dealt with a lot of data, so interfacing with ERP systems, or also for insurances, where you have like insurance applications, so highly data-centric applications, where a lot of the unit tests would be like, hey, that standard thing that should work with some change, does it have that effect? And so that's something I like to do with builders. So I had this builder generator, which for any data class would generate a builder. So could, for example, have a default contract builder with all the default values set up. And then I could call something like, in this case, without something or with something. So for example, insurance application dot contact details dot without postal code dot build, and then use that object for tests. So that's just something that saved me a lot of code while writing applications. So, are there any questions? Okay, if not, I'm still available. The code is on GitHub. Or there's
Yeah, you mentioned .NET Framework. You can actually generate a compile, create like a code value for .NET Framework.
Okay, so the question was, since I mentioned .NET Framework, can I write a generator that works on .NET Framework? The answer to this is yes, but. So you need to make sure that you're using the up-to-date Roslyn 3 or 4 compilers, so in Visual Studio 2019 or 2022, or the appropriate SDKs. You should also make sure that you set the C# language version to at least 9. So for example, you could also do this on older .NET Core versions, or .NET 5, .NET Core 3.1, etc. But you would need to set the C# version to a higher level to be able to use that feature. But yes, it should be usable. And also some of these generators, for example, the Microsoft Extensions logging generator, that it is also available everywhere you can use the NuGet package. So if you have a .NET Framework application, I think Microsoft Extensions logging is still a .NET Standard 2 package, at least the 6 version was one. So you could also have to generate a feature in .NET Framework. Okay, then thank you and see you around.